Hello! Today we'll be working on antiderivatives and particular solutions. Let's get started. Now, let's start with antiderivatives. What is it? An antiderivative is the inverse of a derivative. The process of antidifferentiation is known as integration. Integration is shown by this symbol. That means whatever's inside of it will be integrated. The inside of any integration problem will look like this. F of x dx. The f of x is the integrand, and the dx is the differential. And the solution is going to look like this. And the bigger f means that it's the integrated form of the previous function plus c, a constant. A simple integration problem will look like this. The function you're given, f of x, will equal, how about 3x to the fifth? To begin, we go back to this symbol and put it in this format. So integration sign, 3x to the fifth dx. So, we'll start with the 3. Because it's a constant, we can pull it out of the equation and deal with it later. To differentiate, you take the exponent and add 1 to it, and then put that entire thing over the exponent plus 1. So this is going to be x to the 6th over 6. And you bring the 3 right back down. So 3x to the 6th over 6. As you can see, the 3 and the 6 can cancel out. So you just have x to the 6th over 2 equals big F of x. Oh, and don't forget, plus c, because it's a constant. You have to add the constant. And that's your solution. Now, this one looks a little bit more complicated. It has 3 parts. I've already walked through it, so now I'll just explain. So we have 3x to the 5th minus 2x plus 6 over x squared. I simplified this and put it into the integration symbol by just bringing down these, and I simplified this term to be 6x to the negative 2, so it was easier to work with. Now this looks familiar from our last problem, so I already knew it would be 3x to the 6th over 6. The minus 2x just becomes negative 2x squared over 2, and the 2's cancel. And the plus 6x squared becomes plus 6x to the negative 1 over negative 1. This all simplifies to x to the 6 over 2 minus x squared minus 6 over x. And as we always have to do, add c. And that c is actually going to be what we're solving for when we're finding particular solutions. So it's actually a very important part of antiderivatives. So now that we're on the topic of particular solution, why don't we just try it with this problem? Now, what you need for a particular solution is this general equation, but you also need an initial condition, where x is given a number and it equals a y value. So, for this problem, we're going to try f of 1 equals 5. So, you find the derivative, which we have already done, which equals x to the 6th over 2 minus x squared minus 6 over x plus c. Now, we plug in 1 wherever we see an x. I'll just simplify this, so it's just going to be 1/2 minus 1 minus 6 plus c equals 5. That's where we're getting that 5. Now, this also, no cell phones in class, ladies. And now, to simplify this, it actually ends up equaling 11.5 equals c. And then you write the equation again with the c. So it's going to be x to the 6th over 2 minus x squared minus 6 over x plus 11.5. And that is how you do particular solution. I hope you learned a lot in this lovely lesson. Now time for some bloopers. So now that we're on the topic of principal... Now, let's try a problem that's a little bit more complicated. How about f of x equals 3x to the fifth minus 2x plus 6 over x squared? It might look... I'm wearing my underwear.